Okay, so in this problem, we'll just do the decomposition into partial fractions. So we want to decompose this rational function x cubed minus 2 divided by x to the 4 minus 1. The important thing to recognize here is we have a difference of squares in the bottom, x to the 4 minus 1. So let me write this down. We have x to the 4 minus 1 at the bottom. That can be written as x squared squared minus 1 squared squared. So that's a difference of squares. So that should be x squared plus 1 squared times x squared minus 1 squared. And we have another difference of squares here. So this can be decomposed again, but this cannot decompose. X squared plus 1 is not difference of squares. That's sum of squares. So that cannot be factored. So we will keep x squared plus 1. So I'm not going to write 1 squared. I'm just going to write that as 1. And this would be x plus 1 times x minus 1. Okay, so basically we have x cubed minus 2 divided by x to the 4 minus 1. It can be written as x cubed minus 2 divided by x squared plus 1 times x plus 1 times x minus 1. So we have done the factoring of the bottom polynomials as far as we could. So the trick here is to write this as sum of partial fractions, and this is the first time we have encountered a factor which is a quadratic factor, x squared plus 1, and that cannot be further factored into linear factors, so that's a irreducible quadratic factor. And when we write this as sum of partial fractions, we have to treat this in this fashion. This becomes ax plus b divided by x squared plus 1 plus c over x plus 1 plus d over x minus 1. If we multiply both sides of this equation by x to the 4 minus 1, we get x cubed minus 2 equals ax plus b times x squared minus 1 plus c times x squared plus 1 times x minus 1 plus d times x squared plus 1 times x minus 1. I noticed I made a slight error here. This should be really plus 1. Okay. All right. Now we'll need to distribute this. Let's distribute the left hand side very carefully. I'm going to consider this first term. Okay, let me distribute that. Well, I am going to have four terms here. Ax times x squared will give me ax cubed. Ax times negative 1 will give me negative ax. b times x squared will give me plus bx squared. B times negative 1 will give me negative b. I'm going to have similar terms when I distribute this middle term and this last term. So let me distribute this middle term now. C times x squared times x will give me cx cubed. So I'm going to write it right under this. C times x squared minus 1 will give me negative cx squared. So I'm going to write that under this. So adding up all the like terms becomes easier. C times 1 times x gives me plus cx. C times 1 times negative 1 will give me negative c. Okay, the last term now. D times x squared times x gives me dx cubed. D times x squared times 1 gives me dx squared plus dx squared. D times 1 times x gives me plus dx. D times 1 gives me plus d. Okay, so I just need to add up all these terms, and I can also do the factoring at the same time. X cubed can be factored out from the first terms in each of these three lines. That gives me a plus c plus d plus x times minus a plus c plus d plus x squared b minus c plus d, and the last term is plus minus b minus c plus d. So all of this is equal to x cubed minus 2. Now from this we can write 4 equations. There is an x cubed term here, there is an x cubed term here. The coefficient of x cubed term on the left hand side is 1. Therefore a plus c plus d is equal to 1. There is no x term on the left hand side, so negative a plus c plus d must be equal to 0. There is no x squared term either on the left hand side, so b minus c plus d equals 0. And the numeric term on both sides must be equal, so negative b minus c plus d must be equal to negative 2. So we have these 4 equations. I'm going to label them: equation 1, equation 2, equation 3, and equation 4. Let's look at equations 1 and 3. Well, actually 1 and 2. Okay, these 2 equations. Let's take a look at this. Well, equation 1 tells you c plus d equals 1 minus a, and if you substitute that in equation 2, you get negative a and c plus d, which I have here. If you replace that with 1 minus a, get minus 1 actually plus 1 minus a is equal to 0, or negative 2a plus 1 equals 0. Therefore, a equals 1/2. Now, if I consider equations 3 and 4, and if I add them up, I see b and b plus negative b, they cancel out. Negative c minus c gives me negative 2c. D plus d gives me plus 2d. 0 minus 2 gives me negative 2. If I divide by 2, I get negative c plus d equals negative 1. Okay. Now let me add up equations 1 and 2. Gives me 2c plus 2d equals 1, or c plus d equals 1/2. If I take these two equations and add them up, okay, I'm going to call this equation 5 and this equation 6. So 6 plus 7, if I add them up, c's cancel out and I get 2d equals negative 1/2, or d equals negative 1/4. If I substitute d value that I just found in equation 6, I get c equals 1/2 minus d. So minus of minus 1/4 becomes plus 1/4, which is 3/4. Okay, so that's the c value. Substituting c and d in either equations 3 or 4, let's do it in 3, will help us evaluate b. So b equals c minus d from equation 3. So if I substitute, I get 3/4 minus 1/4. Actually, it's minus of minus 1/4. That will make it 1/4. So that's 1. So b is equal to 1. So putting it all together, we assumed x squared, x cubed minus 2 over x to the 4 minus 1 is this quantity here as sum of partial fractions. And we calculated the numeric constants a, b, c, and d. So if we put it all together, we get this left hand side is equal to 1/2 x plus 1 over x squared plus 1 plus 3 over 4 times x plus 1 minus 1 over 4 times x minus 1. That's the final answer.